Hello everyone, welcome to Eduxcite classes. My name is Monit and we will today solve 1.4 the motion graphs as discussed in my previous video. So before I move on, just have a quick recap. What are the important points that you have to keep in mind for solving this particular worksheet? Okay, so just pause the video and go through it once. Okay, so you can find out the PDF of this worksheet. The link is given in the description, or you can solve with me. I will give you the time to pause the video and you can solve with me and you can check your answers. Okay, so without wasting time, let us start with the very first question. Pause the video and solve it. Okay, so first part is describe the motion as per the distance versus time graph given to us. So whenever the command term is described, we have to mention from the starting till the end of the journey as per the information provided in the question. Okay, so for here you can say the A part, describe the motion of the train between the two stations. So what we can say is, in the initial, the train is starting from the rest, okay, because it is distance is 0, so you can say the train starts from rest, okay, and then for the first 90 second, you can say first 90 second, you can say the speed is, it is curved upwards, okay, so you can say the first 90 second the train was accelerating, and then you can see it is quite a straight line, which means that the speed is constant for the given distance versus time graph. So you can say from, let us say this is 90 till somewhat near about, you can say 200, right? So this is a straight line, so it then traveled with a constant velocity till 200 second, and then you can say it is decelerating. So, and after that its speed decreases, or you can use the word speed instant of velocity, because we are using constant speed because the distance versus time graph is given to us, and after that speed decreases and reaches, or you can say and become 0 after, you can say, let us say 2, somewhat around here it is almost constant, right? So its speed decreases and becomes 0 at 280 seconds somewhat. Okay, so this is how we can describe the motion of the train. Now the B part, state the distance between the two stations. So it is starting from 0 and now it is becoming rest. So this is approximately, if you look at the graph, this is cutting the y-axis at midway between 3000 and 4000. So I can say the distance between B part, I can say, is 3500 meters. Simple. Now the C part, calculate the maximum speed of the train. Now we know that the maximum speed is the one when the curve is the steepest. Distance time graph slope gives us the speed, right? So the maximum speed will be during this time. So what I will do is, we will find out the gradient at this time. So at 200, you can say it is something around 3000, and at 90 it is something around 800. So I will find out this triangle, the gradient of this, because the gradient of distance versus time graphs gives you the speed, and during this time the curve is the steepest, and that is Why? It will give us the maximum speed. So we know that maximum speed will be the, you find out the gradient, which is 3000 minus 800 divided by 200 minus 90. So this will approximately 3000 minus 800, approximately it will give you 32 divided by 2200 divided by 110. So this will approximately give you 20 meter per second. So this will be your answer for the very C part. And determine the average speed. Now we know that average speed is what? Average speed is the total distance over total time. So average speed will be, total distance was 3500 and total time is 300 seconds. So this will give you 11.7 meter per second. I have already done the calculation, you can try in your calculator. So I hope the question 1 is quite clear. If you have any doubt, just comment below. I will try my level best to discuss with you all. And please share this video with your classmates. Now pause the video and try question number 2. Okay. Now whenever the question says sketch, although we don't need to give the values, but only those values are very specific where there is a particular change in the graph. Those value you have to specify, and it also depends on the number of marks. So just have a look at the number of marks for the question. So generally sketch means just the curve they want. Okay, so let us see in this case what is happening. So this is a displacement time graph I have already made. In your question paper they will give you the space to draw there as well. So a stationary car is 25 meter away. So already it is 25 meter away. 2 seconds later it starts to move further in a straight line from you with a constant acceleration of 1.5 meter per second for 4 seconds. So I can say for the first 2 seconds I can draw it will be a straight because it is not moving for the first 2 seconds. Now you can say it is moving with a constant acceleration of 1.5 meter per second for the 4 seconds. So I have to draw the displacement time graph. So what will be the displacement covered during this 4 seconds? You can find out using S equals to ut plus half a t square, right? This formula is given in your data booklet. So this will be 0 because started from stationary, so initial speed will be 0. So S will be half times acceleration is given 1.5 is 3 by 2 into 4 square. So this and this will be 12. So 12 meter is the displacement covered during those 4 seconds, and already it is 25 meter away from the reference point. So the displacement that I will draw here will be 37, will be somewhat here. So for the next 4 seconds it will be at this point, and it is moving with an acceleration. So acceleration curve in the displacement time graph will be a curved, not a straight line. So I will make a curved upward because it is accelerating, and then it continues with a constant velocity for 8 seconds. So now if it is moving, you can find out the speed v equals to u plus at, right? U is 0, a is 3 by 2, time is 4. So this will be 6 meter per second. So the speed is 6 meter per second and it is moving with, so distance will be speed into time. So this will be 48 meter. Now 48 plus 37 will give you what? The total displacement, which will be nothing but 85 meters. So 85 will be, let us say, somewhat here, and next 8 seconds it will be 14. So it will be a straight line like this. So somewhat the curve look like this. Just check your answer. I hope it is correct. Okay. So this is how we sketch the distance time graph for the given situation. Okay. Now question number 3, just pause and solve. Okay, now in your upcoming classes you might have learned about these type of displacement time graph. This is nothing but an example of a simple harmonic motion, okay, that you will learn in your upcoming classes, or you might have gone through it. So what is happening? Describe the motion represented by the graph which is given. So you can assume this graph as a spring mass system or a pendulum. So you will get a displacement time graph similar to that only. So we can describe this motion. So whenever you are supposed to describe the motion, there are three things that you have to mention. Already displacement time graph is given, so you have to comment on the velocity, when it is maximum, when it is a minimum, and you have to comment on the acceleration. Okay, so the A part I can answer is like the object is oscillating, the object is oscillating, okay, backward and forward, you can say oscillating backward and forward. I am assuming it as a spring mass system, okay, like a spring is attached to a mass, you extend it and then it will move, and as such assuming no loss of energy. Okay, so object is oscillating backward and forward about a reference point, you can say, and it completes, and each cycle, or you can say it completes, and it completes with same time period, where the speed, or you can say where the speed are greatest when the displacement is 0. So when it comes to the mean position, the speed is maximum and the displacement are same on both the sides. Like when it is, if it is extended to this part, it will compress to this part. So if it is x extension, x compression will be there. So they have the same displacement. That is what you can comment on, describe the motion. And the displacement is 0. Also the displacement on either side is same. Either side is constant. Okay, so that is what you can comment on. Now compare the velocities at A and B. Now if you look at A and B, you can see there, so velocity, displacement, time graph, the gradient. So this will be the gradient and like this, and here the gradient, the tangent I will draw, it will be like this and it will be like this. So you can say this is an opposite direction, but they are at the same level. So what you can say, they have the same magnitude. So for B I can say same magnitude but in opposite direction. Okay, when is the object moving with its maximum and minimum velocity? So we know that maximum velocity is when the displacement are 0. So you can say at, let me mark it as P Q R. So maximum is P Q R and minimum velocity will be when the displacement is maximum, which is, you can say, A, or let us say X, Y, Z, because at these point the velocities are 0. Now estimate the value of the maximum and minimum velocity. So maximum we can calculate, minimum is 0. So for maximum, again we use the gradient method. So what you can do is maximum velocity, if I say it will be at 2, so if I want to find out, it will be like this, the tangent will be somewhat like this. Let me zoom in. somewhere it will be like this. So this displacement is 0.5, right, and this is 2. So 2 and this is minus 2. So we can say this is 4 divided by 0.5, right? So the maximum, the D part you can say is maximum velocity is the gradient, which is minus 2 final minus 2 divided by, now they are asking the values, it means they are asking us the magnitude upon 0.5. So this will be 4 upon 0.5, which is give you the 8, and the unit will be centimeter per second. So the maximum will be 8 centimeter per second. And suggest what kind of, as I mentioned, you can say a pendulum or you can say a spring mass system. Both are correct. Okay. Now pause the video for question number 4. Okay. Now this is quite easy. Whenever the curve is like a gradient, when the graph is like a curved part and they ask us to find out the acceleration at a particular instant of time. So the best method is to just take the tangent, draw a tangent at this point at 2 seconds. So tangent will be like this, and just find out the gradient of the tangent at this particular instant. So if it is asked for 2 seconds, so draw a tangent at the 2 second on the curve and measure the slope of the tangent. So this will be change in y over change in x. So acceleration will be change in y over change in x, because that is the velocity versus time graph. So change in y is, this is 4,6 and this is 1,0. So change in y is 6 minus 0 over 4 minus 1, 6 by 3, which is 2 meter per second square. I hope it is quite clear. So make sure you remember this method. This is the most easiest and the fastest way to measure the acceleration at a given instant of time. That is sometimes also known as instantaneous acceleration. Okay. Now pause the question number 5. Okay. Now for the A part, again we have to describe the straight line motion of the object represented by the graph. So we have to start from, so you can say, the object experiences a deceleration for first 4 seconds and comes to rest, or you can say, and the velocity becomes 0 and comes to rest at 4 seconds, and then accelerate in the opposite direction for next 4 seconds, and then moves with a constant velocity. For next 4 seconds. Like this you can mention, or from 8 to 12 like this also you can mention. Now the B part, calculate the acceleration during the first 8 seconds. Now we know that change in the gradient is again the acceleration. So make sure you do not do the calculation mistake. Acceleration will be final velocity minus initial velocity. So final velocity is minus 12, initial velocity was 12, so v minus u upon time taken is 8. So this will be minus 24 by 8, which is minus 3, and the unit will be meter per second square. So this will be the answer for your B part, right? Now the C part says what was the total distance traveled. Now total distance, we know that the area under the curve, the total. So let us say this is A1, this is A2, and this is A3. So the total distance, you can say, is the sum of A1 plus A2 plus A3. So you can calculate A1 is half base into height, which is half 4 into 12 plus half 4 into 12, because we have to take the magnitude only. This is again 4, this is 12, and this is a rectangle. 12 into 4 plus 12 into 4. So if you solve this, you will get 24 plus 24 plus 48, which will be 96 meter. Okay, so this will be your answer for the C part. Now the D part, again they are saying total displacement after 12 seconds. So from here, from the starting till 12 seconds, what will be the total displacement? So these part below the x-axis will be negative. Okay, so this will be like, if I ask you in terms of A, so the total displacement will be A1 minus A2 minus A3. So it will be 24 minus 24 minus 48. So this and this gets cancelled. So answer is minus 48 meter is the answer. Okay, I hope it is quite clear. Now average velocity, everybody knows average velocity is displacement over time. So minus 48, and total time is 12. So this will be minus 4 meter per second. So this will be your answer for the last part. I hope it is quite clear. Do not do these silly mistakes. Make sure that you remember to consider the sign, and below the x-axis the areas for the displacement, if you want to find out, it will be negative, and distance always gets added up. So do not forget this. Now question number 6. Just pause it and solve. Okay. Now the first, it is moving 100 meter with a constant velocity of 25 meter per second. So for covering the 100 meter, it will take 4 seconds, right? So for first 4 seconds, it will be constant at this. Okay. Now after that, 2 seconds after it passes you, the driver decelerates uniformly. So again for the next 2 seconds, it will travel with the same but in opposite direction, because it has passes over you. So if it is approaching you, you have taken positive. If it is moving away from you, it has to be negative. So the directions has to be mentioned. So for me, I have taken this as positive, and if it is moving away, I have taken it as negative. Okay, so this will be the way for this. And now after passing me, the car stopped 62.5 meter away from me. Away from me means for the 2 seconds it already covered 50 meter. So the remaining distance will be 62.5 minus 50 is 12.5 meter. So 12.5 meter is being covered with a deceleration. Okay. Now speed, initial speed is 25 meter per second. Displacement covered 12.5 meter. Okay, now we have to find out the time. So what you can do is, we can use the formula, which is V and it stops. So V is equals to 0. So I can use to find out the first acceleration, I will use v square equals to u square plus 2as. V is 0, u is 25. So square is 625 plus 2a into s is 12.5, right? So this acceleration will give me in negative 12.5 into 2 is 25, and 625 divided by 25 is, so this will give me 25 times 1, 25 times 2, 25. So acceleration is minus of 25 meter per second square, right? And the distance it covered, so I can use s equals v square equals to u square, sorry, v equals to u plus at to find out the time, so, right? So v is 0, u is 25 minus 25 into t. So t will be 1 second. It means that in the next 1 second decelerate uniformly to give. So this will be the graph for your velocity versus time graph. Okay. So what you can do is you can also draw the opposite side as well. What do you mean by opposite side? This can be here and this part can be like this. Like this also you can draw. Okay. Now pause for the question number 7. This is one of the most common question for your paper 1 as well and paper 2 also. Okay. Now you can see we have to draw all displacement time, velocity time and acceleration time for a bouncing ball that was dropped from rest. So what will happen is this will go, I will take the upward as positive and downward as negative as usual. So it is moving in the downward direction, right? So it will go like this, it will bounce again, it will go like this and like this. So we have to do for the 3 times the ball contacts the ground. So this is the first and then second and then third. So till here we have to draw the graphs. Okay. So just look and check your answers. So displacement, so it is already at a certain height. So this will go like this. Smooth curve you have to draw. It will become 0 at here. It will come down like this and it will go like this. So this is the first time it touches the ground, this is the second time and this is the third time. These are where it is at as a maximum height. So you can mention it as h. So this will be my displacement time graph. Okay, now for velocity I have taken the downward direction as negative, right? So initially what will happen is as the object is dropped, it will gain it will gain velocity but in opposite direction because the acceleration is also in the downward direction. So the velocity will increase but in negative direction with a straight line because it is a uniform acceleration, and I will show with a dashed line because this shows the bouncing of the ball. I am assuming no loss of energy, elastic collision. Okay, elastic collision with the ground, no loss of energy. There is no loss, so it will reach to the same height again. And here it reaches, now it touches the ground. Here this is the bouncing and then it is moving in the upward direction. Now upward is taken as positive. So as it moves upward, the velocity will keeps on decreasing. It will reach a maximum height and then again this is the point at which it reaches the maximum height. This is the maximum height. This is the maximum height. The velocity will be 0. Make sure that it matches with your displacement time graph. So this is the first bounce. Okay. Then this will be your second bounce. Again it will repeat and it will go like this. And here it will be the third bounce. And it keeps on. So the first, second and third. It will be like this. I hope it is quite clear. And we know that acceleration is the constant gravitational acceleration. So you can draw a straight line because the downward direction is negative, so minus 9.8 meter per second square. With respect to time, there is no change in the acceleration. So it will be a straight line in below the x-axis in negative y. Okay. Now this is a very good question. I hope majority of you might not be able to do. Let's see if you have done it in the very first attempt. Please comment below. Pause it and solve. Let's see if you can solve it. Okay. So in these type of question, what you are supposed to do is first read out the question very carefully. What are the information given? So this is the car. I have to first, okay, you have to push the car. You can give the acceleration maximum of 2 meter per second square by pushing, and because if you are pushing, it will gain some velocity, and you have to pull it back in order to stop the car and park it in the garage, right? So the deceleration, or you can say the pulling back, is 3 meter per second square, assuming it is as a constant, and these are the point objects. Now the best way to solve these type of problem is to draw a velocity versus time graph. How? Just look here. So I don't know the time, I don't know the velocity, I will assume. So let us say this is my velocity versus time graph. Okay. Okay, this is my velocity versus time graph. So it initially I am accelerating it, so it will move to a certain velocity, let us say, and after this I will decelerate it and I will make it stop at this time. So let us say this is time small t, this is time capital T, and let us say this is velocity v. Okay, so this is the maximum velocity it reaches, and this acceleration is 2 meter per second square, and here the deceleration is 3 meter per second square. So what is v in terms of this? So I can say, as per the graph, I can say v is equals to u is 0, u plus at. So v u is 0, acceleration is given to us, and time I have taken t. So what I can say is small v is equals to 2 into small t, right? So this is my first equation. Now during the deceleration, what is happening? This is for acceleration. Okay. Now I am doing for deceleration. So for deceleration, the final velocity is 0. Initial velocity is v. Time I have taken as capital T minus small t, because this is the total time. Okay, so this is the time during it I am pulling it back, and acceleration is given to as 3 meter per second square. So again I am using v equals to u plus at. V is 0, u is v, plus a is 3. Now this is a negative, right? So minus 3 into t is capital T minus small t. So solve this 0, v minus, so instead of v I can write 2t minus 3t plus 3t, right? So this will be 0 equals to 5t minus 3t, and from here I can say small t is equals to 3t by 5. So we got relation of t and small t and capital T. Also one important information is given as 15 meter is the total displacement, and the area under the velocity versus time graph is it is in positive, so distance displacement is the same. So if area is 15 meter and the area is half base into height, so what we can say, base is capital T and height is v. So I can say 15 is equals to half times t, and v is 2 times of small t, because we know that v is 2t from the above equation. So this will be 3t by 5. Now if you solve this 2 and 2 gets cancelled. This will be 15 into 5 divided by 3 as t square. So this will be 5 into 5 equals to 2. So t is equals to 5 second. So the answer for this will be 5 second. Okay. So just make the graph of velocity versus time graph in these type of situation, just check which graph will give you the best answer. Assume the information given in the graph, assume the variables which we don't know, and try to make out the relation between them and solve it. You need some practice, but you can do it, right? Now the MCQs. Try for question number 1. Yeah, this is quite easy. Yes, W is the right answer. Most steepest curve will be having the greatest speed, right? So this is the steepest curve, or you can say in the less time more distance is covered, so the speed will be maximum. Pause this and try. Okay, yeah. Now here you can see the velocity is first decreasing, it becomes 0 and it is increasing, right? And it is in the same direction. So acceleration will be in the same direction. Same direction means to say that the acceleration will not change, it is constant throughout. So acceleration is increasing at a constant rate. It is not constant value, it is increasing at a constant rate because it is a curved line, it is not a straight line. If it was a straight line, the acceleration was constant. So this is incorrect. It is the acceleration is 0 at this point because the velocity is acceleration will be maximum at this point because velocity is changing its value at this particular front. So it is decreasing and then it is increasing. So the acceleration will become 0 at this particular instant of time because it is parallel with the y-axis. So this is also incorrect. Now if you look at option A and C, it shows the best representation. So here the acceleration is decreasing and here the acceleration is increasing. So the answer will be A. So here it is acceleration is decreasing, it becomes 0 and then it is increasing. So this will be the best representation for the velocity versus time graph. Okay. Now try the question number 3. Okay. So object is at rest at time equals to t equals to 0 and we have to find out the velocity of the object at t equals to 6 seconds. So for this you have to remember one thing, the acceleration versus time graphs gives us the change in velocity. So at 6 seconds this is the case, right? And this will be 12. So the area of this graphs gives you change in velocity. So area is half, base is 6, height is 12. So this will give you 36 and this 36 is V minus U and U is 0. So V is 36. So option C is the right answer. Okay. Now question number 4, again it's a quite easy one, direct, just pause it and solve. Yeah, so this will give you the speed of the spaceship at t equals to capital B because again it was at rest. So this area will directly give you the speed at t equals to capital T. Okay. Now solve question number 5. Yeah, it's quite easy. The drop from rest in oil, so it will increase speed up to a certain limit, then it will balance out the forces and it will reach a terminal velocity, or you can say terminal speed. So option A is the right answer, rest all are incorrect. Now solve the question number 6 and 7 in one go. Okay. So the best estimate, we have to give an estimate because it's a curved line, we cannot find out the direct answer. So just whatever we can do, so half base into height, so half 5 into 8, so this will give you 20. So it will be greater than 20 because we have not considered this part, and it cannot be 40. So the option is C, right? So option will be C, or you can just calculate or give a rough estimate. Now instantaneous acceleration at 2 seconds. So at 2 second, if you see, we have to again draw a tangent at 2 second. So this will be the tangent. So the change in y, so 8 minus 4 upon 4 minus 0. So this will be 4 by 4, which is 1. So option A is the right answer. Just draw the tangent and find out the slope of the tangent. That will be your answer for the acceleration at that instant of time if a velocity versus time graph is given to you. You can same use the method for speed versus displacement versus time, or distance versus time, to find out the instantaneous speed if it is a curved line. Okay. Now just pause it and solve. Okay, so how many times the car changes direction? So always remember, whenever there is a velocity is moving from positive to negative or negative to positive, there is velocity becomes 0. At that point, always remember there is a change in direction. So 1, 2. So option B is the right answer. So I have tried my level best to cover all the different types of question for the motion related graphical representation of the motion. If you have not understood any question, just comment below. I will try my level best to revert you back as earliest as possible. And please share this video with your friends, classmates, whosoever is dealing with the IBDP physics. If you know, please share with them so that it reaches to the masses. That is the only purpose of making these videos. Okay, so that's all from my side. See you in the next video. Keep learning. Bye bye.